In this video, we're going to be looking at the intersection of a line and a curve. And there are three situations that you need to be aware of. So there's the most common situation that, that we meet when we're solving problems. And that's when we have distinct values. So we have distinct intersection points. So here is a line intersecting a parabola, for example. Or you might have a cubic and the line intersects the curve at 3 points, for example. Okay, so it is intersecting the curve at 3 distinct points, or 2 distinct points in this case. We could also have the situation of the circle, so a line just going straight through the circle and having these 2 distinct points of intersection. Okay, now situations when you get down to the algebra side of it might look something like x plus 2, x minus 3 equals 0, for example. You get down to solving that equation, where you have minus 2 and 3 being the x ordinates of these intersection points. Or here you might have x plus 5, x plus 3, x minus 1 equals 0, for example. So you have 3 distinct brackets. Or in a similar way, you could get down to like x plus 2, x minus 3 with this one. Okay? Now, obviously, when you're thinking about it, oh, well, where is this equation of the circle gone to? Well, what I'm talking about here is that when you're solving the intersection of a circle and a straight line, you're going to substitute the equation of the straight line into the circle, and what's going to happen is that you're going to end up with a quadratic, which may well factorise to get you 2 distinct x values. Okay? So I will show an example of that in the next video. So that is kind of like your first situation. Then the second is where you have a repeated value. So it may well be that we're looking at this parabola again, and the line is a tangent to that parabola. Okay, so you'd have the situation of something like x plus 1 squared equals 0 when you've simplified the algebra far enough. You've got that repeated root. Or with a cubic, you might have a situation that looks like this, where the line is a tangent at 1 point, but there is a distinct value over here. Okay, so this could be something like x plus 2 squared x minus 3 equals 0, for example. That might be the situation that you get with the algebra. With a circle, we know that a tangent line, well, how to find the equation of a tangent line, but this might also be the situation where you have that 1 repeated value. And in a similar way, once you reduce the algebra, you get down to something like x plus 1 squared equals 0, for example. And it shows that there is just one solution, one point where the line intersects the circle, and hence it is a tangent. So this is kind of your second situation, where you have this repeated value, where you have the line being a tangent to the curve at 1 or more points. And then the third and final situation is if the line completely misses the curve. Okay, so for our parabola, we would have this situation here. Okay, or for a cubic, I can't actually draw that, but what we could have for the circle, I won't draw it for that one. But for a circle, we could just have the line completely missing the circle, for example, like that. Okay? Now, algebraically, what's the situation going to come down to? Well, it's going to come down to a quadratic that cannot be solved. So you may well substitute in the equation of the line into the equation of the parabola or into the equation of the circle, and you get down to something that doesn't factorise, and its discriminant is less than 0. So you have something like x squared, I don't know, plus x plus 100 equals 0, for example. A quadratic that cannot be solved, has no real solutions. And so this idea of the discriminant coming in is very important, so that for these three situations, or rather if we just keep with the circles, because we might get a little bit confused with the cubics, but if you get down to a quadratic, which each of these three situations are, the discriminant will tell you how many solutions you're looking at, because the discriminant in this case would be greater than 0. It would be equal to 0 in the case of repeated root, okay, so the line is a tangent to the circle, and it would be negative if the line completely misses the circle. Okay, so we're going to see an example of this in the next video.